Chapter 3. Rational Numbers. In our earlier classes, we have learnt about natural numbers, whole numbers and integers. Let us recollect what we have learnt. Natural numbers 1, 2, 3, 4, 5 are natural numbers. Whole numbers 0 is included with set of natural numbers, that is 0, 1, 2, 3, 4, 5, 6 are whole numbers. Integers negative of natural numbers are included with set of whole numbers. That is, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. We are also familiar with fractions. Fractions are part of whole. In fractions, both the denominator and numerator are natural numbers. Let us take some example. A. 10 divided by 5 equals 2. 2 is an integer. B. -10 divided by 5 is equal to -2. -2 is an integer. C. -1 divided by -10 is equal to 1 upon 10. 1 upon 10 is not an integer. -1 divided by 10 is equal to -1 upon 10 -1 upon 10 is not an integer. Besides natural numbers, whole numbers and integers, there are positive and negative fractions. The system which includes these numbers is called rational number system. We will study about rational numbers along with the 4 basic mathematical operations. Rational numbers. The word rational comes from the term ratio. Rational numbers are the ones that can be expressed in the ratio A upon B, where A and B are integers and B is not equal to 0. In any fraction the denominator cannot be 0 since division by 0 is meaningless. All fractions are rational numbers and all integers are also rational numbers because 5 can be written as 5 upon 1 in fractional form. For example, 3 upon 4 minus 4 upon 5 to 3 upon 4 minus 11 upon 7, etc. 3 upon 4 is a rational number as 3 and 4 are integers and the denominator 4 is not equal to 0. Similarly, -4 upon 5 to 3 upon 4 minus 11 upon 7 are all rational numbers. All integers like 3, -6, 37, -15 are rational numbers since 3 is equal to 3 upon 1. -6 is equal to -6 upon 1, 37 is equal to 37 upon 1 and -15 is equal to -15 upon 1. All these integers can be expressed in rational form. 0 is also a rational number since 0 can be written as 0 upon 10 or 0 upon 20, etc. There are 2 types of rational numbers. 1. Positive rational numbers. 2. Negative rational numbers. Positive rational numbers. If both the numerator and denominator of a rational number have same sign, i.e. either both are positive or both are negative, then the number is a positive rational number. Example: 8 upon 9, 24 upon 55. 101 upon 201, -7 upon -8, -37 upon -47, -151 upon -325, etc. Negative rational numbers. If the numerator and denominator of a rational number have opposite signs, then the number is a negative rational number. Examples: -5 upon 7, -27 upon 29, -143 upon 159, 225 upon -337, etc. Some important findings. 0 is a rational number since 0 can be expressed as 0 upon 50, 0 upon minus 121, 0 upon 72, 0 upon minus 205, etc. 2. Every natural number is a rational number, but every rational number may not be a natural number. Examples: A. 9 upon 10 is a rational number but not a natural number. B. 9 upon 1 is a rational number and it is also a natural number. 3. Every integer is a rational number but every rational number may or may not be an integer. Examples: A. minus 7 is an integer. B. minus 7 can be expressed as minus 7 upon 1 and is also a rational number. C. 21 upon 7 is a rational number. 21 upon 7 is equal to 3 and 3 is an integer. D. 5 upon 7 is a rational number but not an integer. 4. Every fraction is a rational number but every rational number may or may not be a fraction. Examples: A. 7 upon 8 is a fraction and rational number as well. B. minus 7 upon 8 is a rational number but not a fraction. Rational numbers on a number line. We know positive numbers are represented to the right of 0 and negative numbers to the left of 0. The same principle applies for rational numbers also. When we express a rational number on the number line, we divide the unit length into the number of equal parts as the denominator of rational number and then mark the required rational number on the line. Let us study some examples. Example 1. Represent 4 upon 5 on the number line. Solution: since denominator is 5, so we have to divide unit length into 5 equal parts. As the rational number is a positive number, we have to go right of 0. A. 0. 1 upon 5. 2 upon 5. 3 upon 5. 4 upon 5. 1. Here each part towards right of 0 represents 1 upon 5. So, fourth part towards right of 0 will represent 4 upon 5. Pointer represents 4 upon 5 on the number line. Standard or lowest form of rational numbers. In our earlier classes, we have studied fraction in simplest form or lowest form. Lowest form means both numerator and denominator have no common factor other than 1. Same principle applies for rational numbers also. A upon B is said to be in lowest form if denominator B is positive and A and B have no common factor other than 1. To reduce a rational number to its standard or lowest form, we use any one of the two following methods. 1. Successive division of both numerator and denominator by a common factor till no common factor other than 1 is found. 2. Dividing both numerator and denominator by their HCF. Ignore the negative sign, if any. Example 1. Express the following rational numbers in standard form. Minus 15 upon 75. Minus 12 upon minus 48. 13 upon minus 39. Solution: A. We have minus 15 upon 75. Find the HCF of 15 and 75. 15 is equal to 3 multiply 5. HCF of 15 and 75 is 15. 75 is equal to 3 multiply 5 multiply 5. HCF is equal to 3 multiply 5 is equal to 15. Divide both the numerator and denominator by 15. Minus 15 divided by 15 upon 75 divided by 15 is equal to minus 1 upon 5. Thus, the standard form of Minus 15 upon 75 is minus 1 upon 5. B. We have minus 12 upon minus 48. Change the denominator into positive. We get minus 12 upon minus 48. Find the HCF of 12 and 48. 12 is equal to 3 multiply 2 multiply 2. 48 is equal to 3 multiply 2 multiply 2 multiply 2 multiply 2. HCF is 12. HCF is equal to 3 multiply 2 multiply 2 is equal to 12. Divide both the numerator and denominator by 12, we get 12 divided by 12 upon 48 divided by 12 equals 1 upon 4. So, the standard form of minus 12 upon minus 48 is 1 upon 4. Solution. C. We have 13 upon minus 39. Change the denominator into positive. We get 13 upon minus 39 is equal to minus 13 upon minus 39. Multiply minus 1 upon minus 1 is equal to minus 13 upon 39. Find the HCF of 13 and 39. HCF is 13. 13 is equal to 13 multiply 1. 39 is equal to 13 multiply 3. Divide both the numerator and denominator by 13. HCF is equal to 13. Minus 13 divided by 13 upon 39 divided by 13 is equal to minus 1 upon 3. So, the standard form of 13 upon minus 39 is equal to minus 1 upon 3. Absolute value of rational numbers. We have learnt that absolute value of any number is always positive irrespective of its sign. Same principle applies in finding absolute value of rational number also. If A upon B is a rational number, B is not equal to 2000, then A upon B is equal to A upon B, minus A upon B is equal to A upon B. A upon minus B is equal to A upon B. Minus A upon minus B is equal to A upon B. Examples. A minus 12 upon 17 is equal to minus 12 upon 17 is equal to 12 upon 17. B minus 12 upon 17 is equal to minus 12 upon 17 is equal to 12 upon 17. C 12 upon minus 17 is equal to 12 upon minus 17 is equal to 12 upon 17. D minus 12 upon minus 17 is equal to minus 12 upon minus 17 is equal to 12 upon 17.